Welcome to the third edition of the Women in TechWorks webinar series. These recordings and the previous two broadcasts are available to watch right now on the TechWorks YouTube channel. If you're watching this live, I'll put the link in Zoom chat. So Women in TechWorks was officially launched last month in London, and so far the response has been phenomenal. And the momentum continues tomorrow with a Women in TechWorks online town hall meeting. If you're watching this live, again, I'll put the link for that in Zoom chat in just a few moments, and you can see all the details there. Our guest today is Dr. Suzanne Costello, who joins us from leafy Edinburgh. She is presenting From Root Cause to Right First Time, using proactive failure analysis to accelerate innovation. Suzanne, the floor is yours.
Thank you, Chris. Just showing my slides and we'll get going. All right, so yeah, Chris, thank you for that introduction. As I say, I'm Suzanne Costello, CEO of Guys, and I'm going to talk to you today about how to bring quality products to market quickly using proactive failure analysis. Next slide.
You want to go full screen, Suzanne?
Oh, I apologise. I thought I was there already. Hang on.
All right.
2 seconds. Let's go back and do that.
That's all right. Just while you're fiddling about with that, I'll tell everybody that
Yeah,
the next
thank you.
Women in TechWorks webinar following this one, there's not going to be one in December or January, but we will be back in February. We've got a load of speakers in store in 2026. So look out for details of the next Women in TechWorks webinar, which, like I say, is coming up in February 2026. I'll also mention that next week in London, the Black Tie event of the year takes place at the Royal Lancaster Hotel. It's the annual TechWorks Awards and annual dinner. It's a very posh event. One of the award categories is a brand new one, and it's the Women in TechWorks Awards. And I'm pleased to announce that the nominees are Katrina Wright of Chipletti, Carol Marsh of Celestia, and Jen Walls of Classic. So the sponsor of this award category is Microtech Global, and we'll find out who the winner is on Wednesday, the 3rd of December. As I speak, there are a final few seats left for this event, and I'll put the link with all the event details in Zoom chat for those watching live. So, Suzanne, it looks like you're ready to go. I will leave you to it.
Thanks, Chris. That was a seamless little interlude for you to give that information. So it sounds very exciting. So back to the webinar today, bit of an overview of what we'll talk about. So I'm going to go firstly through an introduction to myself and Forensic Eyes. We'll talk a little bit about the semiconductor industry, UK opportunities in particular. And then a bit of a deep dive into reactive and proactive failure analysis. What do I mean by all of that? Where did you get started with it? And a summary and questions over to you for that. Okay, so here's my timeline. Very vague, so I don't give away too many clues. But I wanted to tell you a little bit about myself, first of all. So my kind of journey with technology started when I was very young. When I was little, I loved nothing more than puzzles. Loved them. I was always had my head in a puzzle book, doing different activities, building, designing things. So that's really what I love to do from a very young age. I then got to school, and maths and science was pretty much what I always wanted to do. Loved it. And then did the usual thing, went to the careers advisors and said, okay, this is what I'm good at and this is what I like, what shall I do? And they said, well, you should be a maths or physics teacher. Yeah, as much as admiration as I have for maths and physics teachers, it's certainly not a career path that I felt I could take. I'm not nearly patient enough for that kind of career. So I took myself off to university, went to Heriot Watt and did a master's in physics. When I finished that, I still had no idea what I wanted to do. So I continued on. And one thing I did know is I wanted to do some research that was focused. So not so much blue sky research, but research that I felt could have a direct impact. So I started an engineering doctorate. That was in microsystems engineering, and that's where I got to know about semiconductors and learned a lot about MEMS and test. During that time, I started to volunteer with IMAPS, International Assembly Packaging Society. And when I was there, I also became first female chair of IMAPS UK. And around about the same sort of time, my PhD thesis was converted to a textbook. Um, when I'd started that, I was working with MCS, and MCS is a company failure analysis project. So I learned a lot about my skills in failure analysis from MCS. And they cover a broad range of things in electronics, all the way to large scale machinery. Throughout that time, I also had the opportunity to work with the Scottish Council for Aerospace Defence and Security. And whilst I was there, I represented SMEs at Westminster, so that was quite an exciting path as well. But one thing when I was at MCS was great. I started off in a junior technical role and accelerated through to chief operating officer in that role in that company. But there was always a bit of an itch I wanted to scratch, really, and I left in late 2023 to start Forensic Eyes. And tell you a little bit more about Forensic Eyes. What we actually do is similar in some ways in that we deliver failure analysis projects. So we help other people to solve problems when they encounter them. Sometimes that is reactive. So a problem has happened that you've not expected, and we will get on and help you to understand the root cause of that failure. We also deliver capability uplift. So one of the areas that I realised was that people needed support in was to understand what you can get from failure analysis. So what we do now as well is also go into larger companies, sometimes with smaller groups, so small companies and individuals coming together, and we share and give knowledge on what materials analysis can provide. But really, what Forensic Eyes is all about, why we started it, and what I'm here to talk to you about today is the proactive failure analysis. Now, it's all using all those good failure analysis techniques that I've used for years and years, bringing them forward in development. So to integrate them and use them to accelerate R&D, new product development, and new product implementation. So something I probably don't need to tell you guys too much about on this call is the worldwide semiconductor industry. This is a diagram from TSMC. So we're talking about the big guys, Samsung, Intel, TI. They're all moving. And it's huge capital investment to be able to compete with that kind of development. So what the UK semiconductor and electronics industry is working on is more innovative ways to deliver that. The same kind of performance, but without that 5 nanometer chip development. So one thing that always strikes me is that the UK is often applauded for wonderful R&D, world leading, but then criticised for not managing to commercialise that innovation. So these small companies are really doing a great job to convert and to work in that lower volume production area where we can have a massive impact. The problem they're often faced with, though, is that they can be resource limited. So either with investor deadlines or other deadlines to work to deliver that a successful product in a short time scale. And that's when we get to what do we do about that? Do we want to get things right first time? Or do we go on, fail fast and learn fast? To me, they're actually one and the same things. I think it really very much depends on when you measure failure. So right first time doesn't happen without a few prototypes in the background. But fail fast tends to be people who are probably moving in that fast-paced field where they can declare everything that's gone wrong. To me, that's almost unimportant. What's really important is getting to right via the fastest possible route. And that's what we're here to help and support. Very briefly, I wanted to mention also the users of semiconductors because I see the drive coming from them. Therefore, I think it's really important what is it that they are looking for. Think about it in these different spaces. We've got consumer electronics. They're always strive for more functionality, quicker, faster. This is where really the 5 nanometer stuff comes in. These are the users, high volume, high paced. Medical electronics is also a really interesting area. And it has a real drive for alternative packaging. So that really comes into the UK space and how we are using electronics differently in packaging to provide even more functionality. Now it's highly regulated, which has always been a problem. But these are a few projects we've been working on where we're really seeing the FDA listen and adapt to different ways to measure things. Whereas previously we've used techniques that are known and trusted, ones that are probably appropriate for things like space and defence, but maybe not for medical. So we've got a different requirement for those semiconductors and electronic products. Then we've also got the reliability sector, really. So automotive, aerospace, defence, security, where really that driving factor is high reliability. There tend to be larger companies, slow moving and really very much regulated. Lower volume though. So those devices that are coming on quite quickly through consumer electronics markets, they come into these sorts of sectors and they have to be proven first before they can be used. I'm sure we're all pleased about that. It's something that has to happen. But there is an issue that's facing those users as well, and that is obsolescence. That can be driven by the supply chain because if you think about the big guys, they're making all these chips for people who have a massive volume. In these high reliability sectors, they have requirement for much less volume, and so they don't have that same drive. So when we talk about obsolescence, the issue really is described by the diagram underneath that box. And this shows a very simplified version of what happens normally. So normally they'll procure a product, they'll go through reliability qualifications, maintain that product for use. Then there goes through a period of support and retirement of that product where they're thinking, what are they going to buy in next to replace it, get that qualified, and then move on. But the issue we're facing, timelines of these things are completely different. So the new products are coming in much quicker and are being retired much faster. So once a product's been qualified and goes into use, sometimes these companies are seeing them go to last time buys and things like that. So they're really having to accelerate through that process. So one of the things I wanted to talk about a little bit today was the large companies and how they operate with failure analysis. So we're talking about the Samsung and Vichy, for example, in this country, where they've got large manufacturing sites and they also have on-site FA labs. And it's not all for customer returns, in fact, probably hardly any of it is. Most of it is for continual development of their product. So new designs, new materials and processes. What they do is they learn from failure. So anything that goes through, they're finding out what works, what doesn't work, and their understanding really sparks their innovation. But in the UK, when we're working on much lower volume products with specialist packaging, we don't have that same capability. So generally speaking, we've got an SME community who don't have internal failure analysis labs that they can use for that kind of development work. But we are developing some really interesting and promising devices that we have to move fast to get them through qualification. So again, to that point, fail fast or right first time. Well, it doesn't really matter. But what matters is that we accelerate that through, and using proactive failure analysis is a way to do that. So think a little bit first about reactive failure analysis. This is me pretending to be back at school again, loving my investigations and solutions. So when I was working in reactive failure analysis, this is how I do it. Great, I understand the root cause of the problem. Excellent, it's fantastic. And then I'd look at my customer, expecting them to be happy as well. And usually they are because everybody likes to know what the root cause of the problem is. But then they start to think about, oh God, how much it would cost for me to put this right? When can I put it right? And is it going to affect my reputation? So the truth of the matter is, what I'm feeling through my conversations with customers is that reactive failure analysis is often just too late. And that got us thinking about the cost of poor quality. So it's estimated to be around about 100 times the cost of the product. So if we think about a relatively low cost device, a component, it costs about £1, put that component onto a PCB, the cost starts to ramp up, put the PCB into assembly, and suddenly, however, then put that assembly into a critical application, and it's more than money. So we really do need to think about quality ahead of time. So proactive failure analysis is really about thinking about what we can't find. So I could probably tell you, the number of cases where things have gone wrong. It's aspects of manufacture or design that people know to test and inspect for. That happens quite infrequently. It's always the stuff that we've never thought about that kills a product or causes problems. It's always iceberg under the water. And proactive failure analysis is really that sonar that helps us get and find those unknown unknowns so that we know how to test for them. So putting them side by side for a moment, this is a very much simplified diagram to show that kind of development project. And I think the reactive side of things first, the way we normally design and prototype. We do start off with design, we go to prototype, we do some functional tests. We normally go around that iterative loop to get our prototype working, doing exactly what we wanted to do. We then start to think about actually manufacturing, which is quite different to prototype making. So once we've got a manufacturing process, we probably need to go through that loop a few times as well, because it never works very fine. So we're going through that loop, testing and manufacturing, trying to perfect that manufacturing process. And once we've got that, we've got a product, we then start to test it. And after that, some reactive. So that's when we can start to see failures maybe dropping out of the reliability test, and we need to understand what happened. And when we do it in that way, the problem is we don't know what that analysis will be at the end. We don't know the cost to fix that. The worst of it is if that problem that we find actually requires a redesign, we're going right back to the very top of that loop to solve the issue. With proactive failure analysis, we're doing things alongside. So we're working with people at the right time so that we can make changes when they happen. So after design, we might go to prototype, we'll do some functional testing, but also some proactive failure analysis alongside that. So once we've got a product it's starting to do what we want it to do, maybe it's not, but we find out why. So instead of just going, okay, that didn't quite work, pass our electrical test, we're going to change a few things and try again. We're not just changing a few things, we're going to check out what we need to change and go back and make an informed decision. The same is true with the manufacturing step. Things change through manufacturing processes, but if we can understand what is not working physically, then we can put that right. And we're taking far fewer loops around that iterative step. And with reliability testing, also doing the proactive FA at the same time generally means that we get through it first time. And that's where the right first time thing comes from. The best thing about it, I think, is that at the end of that, even if we haven't found anything that you can change or improve upon, which is very rare indeed, there's always something we can be doing better. But even if we didn't find that, what you've got at the end is a wonderful reference of how of the quality of your product. So we've got all this data that you bodies that will help us to show just how good that product is. So the benefits proactive failure analysis are that it's planned and budgeted for. You know how much you're going to be spending on it throughout that project. Also, the solutions can be identified at the right time. We shortcut that implementation design, that implementation time. So, for example, say we find something that means that prototype's never really going to work until we change a design. It's right up there at the top. It's not, we don't find that out at the end of the process. It's at the time that it's happening where it's much less expensive to put in those changes. So let's talk a little bit about failure analysis and what I mean by that, because there's lots of caveats to that depending where you come from. Because electrical test, for sure, has elements of failure analysis in it as well. Electrical test is also great; it tells us where and when things go wrong, and that's fundamental to what we do as destructive failure analysis people. We need to know when and where to go and check out. So, we work together to get the whole. But for us, the materials hold key to the how and why things fail. And that physical failure analysis often gets us to the root cause and allows us to put in solutions without assumptions. So in pictures, let's show you what I mean by that. So this is actually an image of an LED. It's there in its package, and you can see the wire bond loop. It's within its package and it's sitting on a PCB as well. So we've taken a cross section through the whole thing. It allows us to understand what's happening at various different levels throughout this device. And what I wanted to show you that on this one is the image on the left-hand side of the screen is a zoomed up image of that tiny little wire bond that you see in the centre of the top image. And it's zoomed up so that we can see the interface between the PCB pad and the actual wire bond connection. And what we're able to see there is lots of different patterns in that metal. So hopefully you can see the grayscale change on pattern there. And that kind of information is a clue that we use to understand whether something's been made successful and if there are any problems. And on the right-hand side, it's a similar image, also zoomed in a little further this time, but this is actually on the solder joint connection. And this is the solder joint connecting to the PCB underneath. And what we're looking at here is an intermetallic compound that forms between the solder and the pad that we're making the joint to. And you'll see these tiny black dots at the interface. And those tiny blacks are there because those are species in between. Now, these are absolutely normal, but this is the sort of thing we can use to help us understand whether something is going to survive over time or possibly reliability test or worse in field. So these little holes will, over time, continue to evolve and they'll start to join up. They're called Kirkendall voids for those of you who might know what that is. So what we can do is track how many of these there are and how close they are together. And that helps us to understand if a product like this will pass reliability tests. Another example, this time we're looking at process optimization and qualification. This is a device. It's a fairly old one, but it's a memory device. And through this, what's really great about doing big sections like this, which is done using an iron milling machine, is that we get to see all this detail, wonderful sort of nanometer scale resolution across the whole of a device. And that allows us to characterize a lot of different interfaces at the same time, which is exactly what we want to do with our proactive failure analysis. It gives us lots of information from one sample. In this particular case, we're interested in how much of that wire bond was actually bonded and how much was just sitting on top of the material. So we were really to quantify that so that we knew whether batches were going to be successful. But the point I wanted to share with you here is that we can learn so much about the physical condition across one section. Now moving on to predicting failure. So this example, I should say as well, is not my own. It comes from a paper which is referenced down here, which you can go and have a look at. But I wanted to use it as an to illustrate what I'd like to show you as possible. This is a ball grid array solder joint which has gone through accelerated aging and has cracked at that device interface. So you can see the crack right along the top surface. But if we go back a few steps, pretend you haven't seen this, this solder joint is perfect in its initial form. What we can do using things like this is EBSD, but we can use lots of different techniques, EBSD shown here, to look at the crystal structure. And the crystal structure shows us things happen before we can see physical change. So we can start to see the crystals moving. And these maps, as you'll see going through A to F here, show subtle change over time. You can start to see some information on C, where you can see that interface is starting to change. And at that point, we'd be able to say, okay, great, this component is going to fail there. That's where it's going to fail first. So it can help us to accelerate the accelerated testing. So I've talked a lot about failure analysis techniques and what we need to use, and I've shown you those that are core to what forensic eyes deliver. But the truth of the matter is, we need lots of different techniques, lots of different expertise, and there's no one place we can go to get all of that. But in the UK, we have a thriving network of universities, RTOs, and SMEs who have lots of different skills, experience, and equipment. What we want to do is to try to access and collaborate to deliver from one end to the other a fully integrated FA service. And this is a good point to probably just tell you a little bit about works are currently restarting, led of course by Gillian. So we are hoping to start, and have started, I should say, the failure analysis, characterisation and reliability group again. It looks like I might be chairing that, so looking forward to finding out and getting that started. But what we're really looking to do is to map this capability across the UK so that we can help smaller companies access the services and expertise that they need to be able to deliver their solutions. The way that guys do that currently, I've said already, and I've shown you some of our core techniques that we use. So we have our own skills in doing that. The destructive physical failure analysis is exactly where we sit, but we work very strongly with partners too. So we interpret a lot of data that comes in from others as well and package it all back and give you the questions that you've got. So collaboration is really key with our industry partners. We've got partners across lots of different networks where we are using partners to do non-destructive testing for us. So if we need a bit more of a steer on where to go and look, we can use some techniques there. Surface analysis as well is a really specialist area and needs fantastic equipment to do that. So we've got partners that we work with on that side. Semiconductor chip specialists as well. So we've got the guys who know how to deprocess everything on the semiconductor level, and lots of other elements as well. So what's really important in the work that Forensic Eyes do is that we bring all of that together and we work with your team. So we don't go off and do our own thing and come back with a report. We're very much engaged with you throughout the whole process, and we're trying to implement things with your team. So to summarise what we've talked about today, and what I really wanted to get across was that proactive failure analysis is a way to really move things upstream to accelerate development, spark innovation, and mitigate risk. All the big guys are doing it. All they're all got their internal FA labs where they're learning from failure constantly. And what we really want to do in the UK is show our capability. We have this sort of great supply chain of small, medium enterprises, RTOs, and universities, all with fantastic capability. So us joining together to deliver a really end-to-end programme for FA characterisation and test. So that's really all I had to share with you today. So I was going to hand back to Chris now and see if we've got any questions.
Dr. Suzanne Costello, CEO of Forensic Eyes, thank you very much. So before we get into the Q&A section of today's broadcast, I'll just repeat a couple of things which I mentioned at the start of today's broadcast. Where are we? Tomorrow, we've got a Women in TechWorks online town hall meeting. If you're watching this broadcast live, I'll put the details for that in Zoom chat. In fact, the details for it are already in Zoom chat if you just click on that link before the end of the broadcast. The town hall begins at 11 a.m. online tomorrow. Also, next week in London, the Black Tie event of the year takes place at the Royal Lancaster Hotel. It is the annual TechWorks Awards and Gala dinner. One of the award categories is a brand new one. It's the Women in TechWorks Awards. And the nominees for that are Katrina Wright of Chipletti. She, by the way, was our last webinar guest last month. There's also Carol Marsh of Celestia and Jen Walls of Classic. The sponsor of this award category is Microtech Global, and we'll find out who the winner is on Wednesday, the 3rd of December. As I speak, there's the final few seats left for this event, and I'll put the link in Zoom chat for those watching this live if you would still like to come, but move fast. All right, let's get into the Q&A, Suzanne, and I'll just put myself on screen. If you can let me just fiddle about for a second. That's better. Right, where are we? I'm just going to go into Zoom chat. So this first question, I hope I'm pronouncing this name correctly. Apologies in advance if I'm not. Vibav says, "Hi Suzanne, thanks for sharing the presentation. Just a quick comment on the proactive failure analysis flowchart. We are able to use the lessons learnt from different RCAs and provide suggestions during the design phase to avoid some commonly seen issues, more like design for reliability. And to do so, you also help in ALTs for improving the reliability in early prototype stages. What would you say to all of that?"
I agree fully. Yeah, there's lots of ways, and definitely design for reliability, design for test, design. All of this is critical and plays a part. So yeah, couldn't agree more. It all has to be done to deliver what we're looking to.
All right,
Yeah.
thank you very much for that question, Vipav. Let's scroll down a little bit. Stuart says, "Great presentation, Suzanne. Thanks very much. MCS would love to be a part of the emerging FA capability network. Please let us know how we can get involved."
Yeah, of course. So I say that we're starting that through TechWorks. So watch the space really. So it's really just happening now. We'll be in touch for sure. So I do know sure, obviously. So we'll get in touch with that with you directly, sure.
All right, brilliant, Stuart. Thank you very much. Naresh says, one second. "Can you give me an example where the proactive FA failed to spot failure at prototype and propagate to manufactured product?" There's also a follow-up question. "How does the industry partners taking this approach of proactive FA all the way from proactive to fully manufactured product?" And that question's from Naresh.
All right, okay. So when we haven't, Naresh, and just make sure I've understood your question properly. So you're asking when we haven't managed to find a failure that's gone all the way through to reliability testing. Is that correct? Am I sorry, Chris, I'm asking you really as well to
Um, I'll read it to you again.
Yeah, thank you. That'd be great.
So, can you give me an example where the proactive FA failed to spot failure at prototype and propagate to manufactured product? That was the first part.
Okay, great. Well, I guess an example, it's quite a difficult thing to pick up on an example of that, Naresh, but I can say that, it's that can happen for sure because we can predict everything that's going to happen from prototype. When you go into an actual product that's manufactured, it's going to be made in a completely different way. So we're going to start implementing and using different processes that you wouldn't touch when you're doing prototype. So they will have different fill perhaps different processes needing to be optimized. So that's why we use it all the way through. And even after manufacture, you've got kind of low level volume manufacture, and then you ramp up. And when you ramp up, you also have to go through that step. So as I say, it was really that diagram I shared was simplified, very much so. But yeah, you need to be but catch it at the right time.
Suzanne, can you rewind just 10 seconds there because you dropped out a little bit?
Oh, sorry. Yes. So I'll just repeat what I was saying in a more succinct way. So yes, we have to. I can't really describe a time where we're going to completely fail to spot something, but it will happen because time, it's different manufacturing product than you will when you go to manufacturing processes. The same will happen when you go from ramping up from low volume to high volume. We're using different processes, and therefore there will be different failure modes that we need to identify and fix. So, really, it's about spotting the problems that are occurring at the time that they occur and not waiting until the very end.
Okay, and there was a part two from Naresh. How do the industry partners taking this approach of proactive FA all the way from proactive prototype to fully manufactured product? How do they do that?
So it's really about getting going from the words go. So working as soon as you've got something physical that we can have a look at. So the previous question was about the design stage as well, and that's all very important. But once we've got a physical product, we can start learning from the materials. So it's really about getting in contact and engaging with companies like Forensic Eyes, and we'll help you scope it. So we'll help you go from the start. What do we need to do? When do we need to check? And we can start to scope that kind of project so it can be budgeted for in advance.
All right, I hope that answered your questions, Naresh. Jen asks, or she says first, great presentation, Suzanne. Thanks for sharing your insights. I agree, proactive analysis is always better than reactive, where we in semiconductor manufacturing sometimes find ourselves. Thinking about this up front at the quotation phase for prototyping is now very much in my mind. So more of a comment than a question from Jen, but I'll invite your response to that.
Thanks, Jen. Yeah, I think it's critical, and it's something that we can do. I mean, it's the more we can put into the budget at the start, or the more we know we're going to need, the less risky that becomes further down the line. So I think working on that front is a really sensible approach. So yeah.
Okay. Um, if a company is developing a new product and like the sound of proactive FA, how do they take that further?
It's very similar to Jen's session, probably on that front is just to say, yeah, get in touch and say either through TechWorks, where we've got the group beginning, or come speak to me directly. We can try to do that. As I say, my business is very much operating in the centre there, where we're trying to figure out what it is that you need using the SMEs and universities around about the UK to pull in exactly you'll need to deliver that. So give me a shout. We'll have a chat. We can take it from there.
Okay, and anybody who wants to contact Suzanne directly, there's the LinkedIn link in Zoom chat right now if you scroll back a little bit. Fion says, what are the most common causes of failure that you have seen, and what is the number one piece of advice you would give to electronic designers to prevent that?
Oh, right. So that's a good one. Well, I think without a doubt, it's interconnects. So wherever anything connects from one thing to the other, whether that be a wire bond, a solder joint, a bump bond, anything like that, whenever there's a connection, generally speaking, that's where it feels first. So one of the most important things I would say is really think about packaging. Packaging is more important than perhaps it's given credit for. So that's what I would. My recommendation to a designer would be let's think ahead to packaging.
And I'm just putting in your website URL. into Zoom
Thank
chat
you.
right now for anybody who wants to get in touch and read more about Forensic Eyes, which I've misspelled in Zoom chat. But it's www.forensic-eyes.com. I hope I've gotten that one correct, Suzanne.
That's
Um,
fine.
Thank you very much for your time today, Dr. Suzanne Costello, joining us from Edinburgh, CEO of Forensic Eyes. As I've mentioned a couple of times now, it's the TechWorks Awards and Gala Dinner in London next week on Wednesday, the 3rd of December. And one of the awards that we're all looking forward to in particular is the Women in TechWorks Awards. So I'd like to say good luck to the nominees: Katrina Wright of Tripleti, Carol Marsh of Celestia, and Jen Walls of Classic. That's it from the Women in TechWorks webinar for today and for 2026. We're going to be back in February. No, hang on, let me rewind a second. That's all for 2025. I'm getting my years mixed up. From the Women in TechWorks webinar series, we will be back in February 2026 and we'll look forward to seeing you then. In the meantime, thank you very much, Suzanne, and thank you and bye for now.